Hello, this is Joshua, and this is my CIS 3306 final screencast report. If you watched my earlier screencast, the first draft, you'll see that quite a bit has changed here. But first, let's take a look at how it works. So this is what the Nexus 7 looks like here. This right here, Project 1, is the application. I'll hit that and it starts up. Notice it automatically locks once you go in, and we see a Tetris game going here. Before, we had only a little test screen giving us the inputs. Now we have a full game running, and you'll notice it's actually running pretty smoothly. It's running quite nicely, I would say. The input is coming in and it's being read nicely, maybe even a bit too well at times, but so here I'll show you what clearing a line looks like, if I can do it correctly. Alright, and you see that cleared a line, and then rotating with the buttons, and then I'll show you what it looks like when you lose. See over here we have this game over display, and it says press any button to begin. So it basically just clears the screen and begins again. So that's what that looks like. Let's go back to the code now. So now that we've seen the project in action, let's look at some of the code. If you remember from any of my earlier videos, if you've seen them, this is my screen class, which is a custom surface view. And we have our game thread here. It's all pretty much the same, except now instead of having our test screen, we have an implementation of Tetris, which is a Tetris clone I made for this project to help test this environment. So if we look at Tetris here, we see that it's a class that extends game thread. Now if you remember, game thread over here extends thread, and it has some variables in it. I believe I have since updated a lot of this since my last video. Just put in some extra methods. There's these constructors here, and these constructors are fairly necessary for the implementation of a game. We have all of these abstract methods here, which will be implemented in Tetris. So there's a lot of variables. Then we get to the constructor, and we do the surface holder context. We use a constructor from game thread, and then we just initialize the variables for Tetris. This helps with this method here. Helps add a new tetramino to the screen when one has dropped. And this just updates the little showcase to the side that tells you what the next tetramino is going to be. This just clears the showcase so that you have a clean slate, so you don't have any problems with two different tetraminos, one on top of each other in the showcase. Run is the main area in this thread. We say that while running, do this. And basically we're just saying update and draw. Update here gets user input and updates this field and the variables, all the variables. And then there's this method checklines for when a tetramino has been detected to drop. It'll check all the lines, and if one of the lines is full, it will do this clear line here. We have do start, which initializes a lot of the variables. This is what we use when we get game over. It would probably be advantageous for me to get rid of a lot of the code at the top in the constructor and replace it with this do start method. I plan on doing that at some point, but as yet I have had some things here. We have the pause, unpause, and bundle save state. I really didn't have a need to implement these, so I just needed to put them here and keep them empty. And then do draw just draws everything to the screen. And we have a public void set running, which just sets the running variable and the thread up and run. So then we have Mino. This just does our little boxes. It gives it a X index and a Y index and a color. And then tetramino, it has 4 minos, and it puts them, it's an abstract class that will put the 4 minos into different orientations based on the inherited classes. And we just have all the classes that extend tetramino here. We have box mino. Over here you can see I mino, LL mino. We have an RL mino, S mino, Z mino, and T mino. So these are pretty much all the tetraminos that we'll have. If you notice, we have a down function for each. We have a rotate right, a rotate left, a move left, and a move right. So one thing I'd just like to mention real quick that I think is pretty cool is that in the code, as the tetraminos are dropping, there's only ever one tetramino object. The field itself is just a double array of integers, and each tetramino object as it goes down is just, what it's doing is it's updating the integers in the field array around this tetramino. But as soon as it drops, all the connections to those integers is released, and it goes back up to the top with a new implementation of tetramino. Well, that's all I have for my project. I hope you like it. I'll see you later. Bye.